will be Honors Geometry Chapter 8 review, focusing on proportion theorems and the algebraic quadratic formula. Chapter 8's main objective was to work with similar triangles. We learned that with similar triangles, sides are proportional. In Chapter 8, we also learned about some theorems that result from similar triangles, referred to as the proportion theorems. In the first example, when you have a parallel segment within a triangle that's parallel to one of the sides of the triangle, it divides the other two sides of the triangles proportionally. So if we label the pieces on the left side of the triangle A and B, and the pieces on the right side of the triangle C and D, then the proportion that forms would be that A over B equals C over D. This is often referred to as the side splitter theorem. It's very important to remember that the proportion, or the ratio from the side splitter, is not the same as the ratio of the similar triangles. You do have similar triangles. The smaller red triangle would be similar to the whole larger green triangle. But if I wanted to find the lengths of the parallel segments, for example, if I called this segment here E and this segment F, if I wanted to find the lengths of E or F, I would need to use the ratio of the triangles, which would either be A over A plus B or C over C plus D. So that would come from the similar triangle ratios, not to be confused with the side splitter. Moving on, the second proportion theorem again comes from parallel lines. When you have three or more parallel lines that are intersecting two transversals, they will divide the transversals proportionally in a similar way like side splitter. If I label the sides of the transversals as G and H, J and K, then the parallel lines divide the transversals to create the proportion G over H equals J over K. And finally, the last theorem that we talked about in Chapter 8 involving proportions came from an angle bisector of a triangle. So if I knew that this ray was bisecting the angle, creating two congruent angles, it would also divide the sides of the triangle proportionally. If we labeled the pieces here, W, X, Y, and Z, then the proportion that forms from the angle bisector would be that W over X equals Y over Z. So let's do a practice problem involving the side splitter. In this example, we know that these lines are given parallel. LN is parallel to KP. We know that the length of ML is 1. The length of MK is 4Q. And the length of MN is Q. And finally, the length of NP is 2Q. If we want to work on solving, you have to recognize that the information on the left and the right side are not in the same format. If we want to work with the side splitter, then we need to fill in an expression for KL. If we want to work with the ratio of the similar triangles, then we would need to fill in the length of MP. I'm going to fill in an expression for KL. Since the whole segment is 4Q and LM is 1, then I can call KL 4Q minus 1, which allows me to write the side splitter's proportion of 1 over 4Q minus 1 would be equal to Q over 2Q. From this point, to solve a proportion, remember you cross multiply. 1 times 2Q would result in 2Q equals Q times 4Q minus 1. So start simplifying to solve the equation. We'll have 2Q equals 4Q squared minus Q. Since this is a quadratic, we'll take all terms to one side. 0 equals 4Q squared minus 3q. If we want to work on solving using the quadratic formula, it's important to acknowledge that your constant here is a 0. While this equation can be solved by factoring, I'm going to use quadratic formula just to review that for the final exam. So remembering the quadratic formula, x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Acknowledge that your a is 4, your b is negative 3, and your c is 0. And we'll plug the values into the quadratic formula and solve. So x equals the opposite of b, so positive 3, plus or minus the square root of negative 3 squared minus 4 times 4 times 0, all over 2 times 4. So begin simplifying. We'll have x equals 3 plus or minus the square root of, the second part of the discriminant cancels out because of the value of c, that's 0. So all we have left is a 9 under the square root, all over 2 times 4, which is 8. Simplifying further, we will end up with 3 plus or minus the square root of 9, which is also 3, all over 8. Finally, to get your two answers, we'll do x equals 3 plus 3 divided by 8, which results in 6 over 8, which reduces to 3/4. Or we do x equals 3 minus 3 divided by 8, which results in an answer for a value of x equal to 0. So now that we know our two values are 3/4 and 0, if we plug those values back in, if q were 0, then that would make all the sides, some of the sides 0, so we won't acknowledge that as a solution. We'll just use q equals 3/4. So to find the value of mk, plug in q equals 3/4. 4 times 3/4 results in a value of 3 for mk. To find mn, it's equal to q, so mn's length is just 3/4. And finally, to find the length of np, we'll do 2 times q, so 2 times 3/4, which would make a value of 3 over 2.